Okay, let's jump right into what might be the single most important concept in all of technology today, the difference between AI and AGI. And look, you don't have to be an engineer to get this. Honestly, understanding this is going to be crucial for all of us as we figure out what kind of future we're building. So let's do this. Right off the bat, we need to get one thing straight. The AI we have right now, ChatGPT, the stuff that helps drive cars, it's incredibly powerful, but these are tools. What everyone's actually building toward, this thing called AGI, that's not just a better tool. We're talking about a whole different species of intelligence. And well, that changes everything. So, why does this matter so much? I mean, who cares about the jargon, right? Well, because the way we think about safety, about regulation, about how this technology impacts society, it's completely different for each one. Think about it. You don't regulate a hammer the same way you would a new life form. And that is the scale of the difference we are talking about here. And this slide really gets to the heart of it. On the one hand, you've got our current AI. These are powerful tools, for sure, but they're under our control. They do specific things, and we can regulate them. But on the other hand, you have this theoretical idea of AGI, an intelligence that could match us at, well, everything. It could improve itself, maybe even develop its own goals. And that could be an incredible opportunity or a risk so big we can barely wrap our heads around it. So let's just hammer this home. If you take away just one thing from this first part, let it be this. We are not talking about just a simple software update here. We're talking about the fundamental difference between a better tool and a potential new form of intelligence. All right, so let's bring this all back down to earth for a minute and talk about what we actually have right now. It's a type of AI that insiders call narrow AI, and chances are you're using it every single day, probably without even thinking about it. The definition is right there in the name: artificial, narrow intelligence. Every single AI system on the planet today, and I mean every single one, no exceptions, is designed to do one specific thing. And this just illustrates it perfectly, right? ChatGPT is a wizard with words, but it can't drive a car to save its life. A Tesla can navigate a highway like a pro, but it has no clue how to diagnose a medical condition. AlphaGo can crush the best Go players in the world, but it couldn't even play a simple game of checkers without being totally rebuilt from the ground up. They're all one-trick ponies, just really, really good tricks. It really just boils down to this. These systems can be superhuman at their one job, but step even 1 inch outside that specific domain, and they're completely lost. That's the fundamental nature and the limitation of every AI we have today. Okay, so that's what we have. But what about what we don't have? Let's dive into the big theoretical dream that's driving so much of the research and, let's be honest, so much of the hype: AGI. Artificial General Intelligence. The keyword here is general. An AGI would be a single system that could do pretty much any intellectual task a person can. It could write an amazing novel, then hop in a car and drive it, then diagnose a rare disease, and then decide to learn a brand new skill, all without anyone having to re-engineer it for each new task. And this next point, I cannot say this loudly enough. AGI does not exist. As of right now, it is 100% theoretical. Every news headline you read, every mind-blowing demo you watch, that's all still narrow AI. We are not there yet, not even close. I mean, just look at what AGI would actually need to be able to do. It would have to take what it learns in one area, like physics, and just intuitively apply it to something totally different, like engineering. It would need real abstract reasoning and common sense, all that basic stuff we just know, like you can't push a rope. It would have to learn how to learn new things on its own and mash up information from what it sees, hears, and reads. This is a huge, huge leap from where we are today. So, that leads to the really big question, right? If we have a pretty good idea of what AGI should be, why is it so ridiculously hard to build? Why is the gap between the narrow AI we have and the general intelligence we imagine, why is it so massive? Well, to get the challenge, you have to understand how today's AI works. At its core, it's really just a very, very fancy pattern matching machine. We dump massive amounts of data into it, pictures, text, whatever, and these things called neural networks learn to spot incredibly complex patterns and connections in all that data. It isn't understanding things the way we do, it's just getting insanely good at spotting and recreating those patterns. This is the classic example. You can train a neural network on 1 million pictures of cats, and it will become absolutely phenomenal at identifying cats. But that same network is totally rigid. It can't then turn around and identify a dog or a car or anything else without starting the whole training process over from square one. There's just no flexibility. And this rigidity leads to these enormous fundamental roadblocks on the way to AGI. There's this problem called catastrophic forgetting, which means if you teach an AI to play chess and then you try to teach it checkers, it can literally forget how to play chess. The new knowledge just overwrites the old. Then there's the whole challenge of common sense. How do you program the millions of unwritten rules we all know about the world? And on top of all that, you have the absolutely astronomical need for computing power. Let's just put that last point into perspective, because this is wild. The human brain, the only example of general intelligence we actually know of, runs on about 20 watts of power. That's less than a dim light bulb. The biggest AI models today can require megawatts. We're talking millions of watts, and they're still nowhere near as flexible as your brain. The efficiency gap is just staggering. So let's just put it all together here with a direct comparison. Current AI, it's a one-trick pony. It needs a ton of data, it can't transfer knowledge, and it's basically just matching patterns. AGI? Well, that's the dream of a multi-talented generalist that could learn from just a few examples, apply knowledge everywhere, and actually understand things. One exists, the other doesn't. Okay, so we've covered the what and the why. But what about the how and the when? Even if AGI is just a theory right now, what are the actual paths researchers are taking to maybe, just maybe, get us there? Yeah, that's the billion-dollar question, isn't it? If the challenges are this big, what are people actually doing in labs right now to try and bridge this incredible gap? Well, there's no single magic bullet. People are trying a bunch of different things. Some folks think we can just keep scaling up what we're doing now, just make the models way bigger and feed them way more data. Others are working on totally new kinds of computer chips that actually mimic how the brain is structured. And some are even chasing the super sci-fi goal of basically emulating an entire human brain in a computer. So when might this actually happen? Honestly, nobody knows for sure. The predictions from the experts are all over the place. You've got the super optimists who think we could see AGI in the next 10 or 20 years. Then you have the consensus view from most researchers, which puts it somewhere in the middle of the century, maybe 2050 to 2070. And then you have plenty of pessimists who think it's at least a century away, or that it might not even be possible at all. And that brings us right back to the beginning, doesn't it? Back to why this distinction is so incredibly important. Because if, and it's a big if, we do manage to create AGI, the outcome could go in one of two very extreme directions. It could unlock a future that's better than we can even imagine, curing diseases, solving climate change, exploring the galaxy, or it could create risks we can't even fathom from an intelligence so powerful its goals might not line up with ours. So the difference between the AI we have and the AGI we imagine isn't just a technical detail. It's a world-changing one. It's the difference between a really powerful tool and a powerful partner, or maybe a powerful competitor. And understanding that difference is the very first step toward making sure we choose our path forward wisely. The only question left is, which future are we going to build?